When we look up at the night sky, it feels natural to imagine that the universe must have some kind of boundary. Almost everything we encounter in everyday life has edges or limits. Countries have borders, oceans have coastlines, and even planets have surfaces where their atmospheres end and outer space begins. Because of this, one of the most common questions people ask about the cosmos is both simple and profound. Does the universe have an edge? If you could travel far enough in one direction through space, would you eventually reach some kind of boundary? Would there be a wall, an empty void, or perhaps a region where space simply stops? Modern cosmology suggests that the answer may be far stranger than our intuition expects. According to our best scientific understanding, the universe may not have an edge at all. To understand why, we first need to explore what scientists mean when they talk about the observable universe. Light travels incredibly fast, moving at about 300,000 kilometers per second. Even at that speed, however, it still takes time for light to cross the enormous distances of space. This means that whenever we look into space, we are actually looking back in time. The light from the sun takes about 8 minutes to reach Earth. Light from nearby stars takes years to arrive. When we observe distant galaxies, the light we see today may have been traveling for billions of years before reaching our telescopes. In other words, we are seeing those galaxies as they existed long ago. The universe itself began about 13.8 billion years ago with the event known as the Big Bang. If space were not expanding, we might expect the maximum distance we could see to be roughly 13.8 billion light years. However, the universe has been expanding throughout its history. As space expands, distant galaxies move farther away from us. Because of this expansion, the light we detect today from the most distant regions of the universe actually comes from areas that are now far farther away than 13 billion light years. In fact, the radius of the observable universe is estimated to be about 46 billion light years. This means the entire observable universe spans roughly 92 billion light years across. Within this vast region are hundreds of billions of galaxies, each containing billions or even trillions of stars. Despite its enormous scale, the observable universe represents only the portion of the cosmos whose light has had time to reach us since the Big Bang. Beyond this cosmic horizon lies a much larger region that we simply cannot observe. There may be countless galaxies beyond the observable boundary, continuing indefinitely in every direction. Because we cannot see beyond this horizon, we cannot directly measure how large the universe truly is. It might be unimaginably vast, stretching far beyond what we can observe. Some cosmological models even suggest that the universe could be infinite, extending endlessly without any boundary at all. If the universe has no edge, the next natural question becomes even more intriguing. What is the overall shape of the universe? In everyday life, we tend to imagine space as flat and endless, but modern physics suggests that space itself can have geometry. According to Einstein's theory of general relativity, gravity arises because mass and energy bend the fabric of space and time. Just as a heavy object placed on a stretched rubber sheet creates a depression, massive structures in the universe can curve space-time itself. Because of this, the universe could potentially have different large-scale geometries. One possibility is that the universe is flat, meaning that on the largest scale, space continues forever in every direction without curving back on itself. If this is true, the universe may be infinite in size. Another possibility is that the universe could have a positive curvature similar to the surface of a sphere. The surface of a sphere is finite in area, but has no edges. A traveler moving across it could continue forever without encountering a boundary. In the same way, a three-dimensional universe with positive curvature could be finite, but still have no edge. There's also the possibility of more complex topologies, where space loops back on itself in ways that are difficult to visualize. Observations of the cosmic microwave background radiation provide important clues about the geometry of the universe. This faint radiation is the afterglow of the Big Bang and fills the entire cosmos. Precise measurements of its temperature variation suggest that the universe appears extremely close to flat on the largest observable scales. This observation supports the idea that the universe may extend far beyond the limits of what we can see. Another key discovery in modern cosmology is that the universe is not only expanding, but that the rate of expansion is accelerating. This phenomenon is believed to be driven by a mysterious form of energy known as dark energy. Dark energy appears to make up about 70% of the total energy content of the universe. As the universe continues to expand, distant galaxies move farther away from us over time. Some galaxies are already so distant that their light will never reach Earth because space between us and them is expanding too quickly. In the far future, observers in the Milky Way may see far fewer galaxies than we see today, because many will have moved beyond the observable horizon. This means that the visible universe changes over time. The cosmic horizon slowly shifts as the universe expands. Yet even as our view of the cosmos evolves, the deeper question remains: what lies beyond the observable universe? At present, we have no direct way to observe regions beyond our cosmic horizon. Those regions are forever hidden from our telescopes because their light cannot reach us. Nevertheless, theoretical models suggest that the universe beyond our horizon may look very similar to the region we can observe, filled with galaxies, stars, and cosmic structures. Understanding whether the universe has an edge may ultimately depend on new discoveries in physics and cosmology. Future observations, improved telescopes, and new theoretical insights may help scientists better understand the true size and shape of the cosmos. For now, however, the universe remains one of the greatest mysteries humanity has ever attempted to understand. The idea that the universe may extend endlessly beyond our vision challenges our imagination. Even though we may never reach the edge of the cosmos, the search for answers continues to drive some of the most ambitious scientific investigations ever undertaken.